Okay, now for reassembly. The cleaned bearings have been greased. Not excessively so, but I'm going to be taking this. You don't need much grease, really. And I'll be taking this apart again in a week or so when I get the, a couple weeks from now, when I get the electric kit. Because I'm going to be wiring, I'm going to be putting wiring inside of the tubing. And so I may want to route wiring, electric power wiring through the bottom bracket possibly. But I'm going to fit the bottom bracket with a grease fitting so that I can pump this full of a soft grease after I seal off these holes. I don't want any water to ever get into the bottom bracket. Of course, I'll have to seal off the holes at the other ends of the tubing. So let's assemble this. Here's our one-piece forged crank with a replaceable chain ring. This would be called the cup. And if I needed to change this chain ring for any reason to a larger or a smaller size, it could be done. Let's put on a bearing, remembering the orientation. You see the balls? You see the cage holding the balls? They go on this way. Okay, so the chain is on the other side of the bike. Slip this through. This is like the second time I've ever done this in my life, so expect me to fumble. Now, we put on the other set of greased ball bearings with the outside of the cage facing outside. All right. Now, this is a cone. It's left-hand threaded. I've given it a light smear of grease. It's hard chromed for wear resistance. But these are not really precision parts, particularly these ball bearing units are not precision. Now I find the thread, and normally this is left-hand thread, so it's going to go on. Don't force anything. Find the thread, and look, I'm spinning it on the opposite of the way you would normally spin on, because this is left-hand thread. You have to remember that. Reed has to remember that anyway. Now, because I'm using a rather thick grease, thicker than I want, lefty loose. Let's loosen that up a little bit until the crank has a little bit of shake. This is where the guesswork comes in, and I'm going to turn the camera off. Here's our tabbed washer. There's a spline there. The tabbed washer. This is just like automobiles, really. Model T bearings are very similar. Now, here's the hard part for me. This thin nut, left-hand thread. Find the thread to start it by hand. Don't force it or you'll cross-thread it. And if I can't find it in the next 5 seconds, I'm going to shut off the camera. Okay, found the thread. So we tighten this down. And this is where it gets fiddly, because when I tighten this, it's going to compress everything inward. So the slight shake that I have in the crank right now probably will disappear, and the crank will bind. This is, it should be a 32mm wrench. So it's a crescent wrench, it's rather crude. As I tighten this down, yep, the crank is binding. So loosen the lock nut. I'm just going to show you once. Loosen the lock nut, then you can then turn the cone lefty loose just a bit. Now try tightening the lock nut again. It goes that way. Bring it all snug. And that's not binding. That's pretty good. I'm going to turn the camera off, make my final adjustment off camera, because I may have to do it a dozen times before I get it right. All right. This is as good as I'm going to get it. Let's zoom in a bit. Because of the imperfection of the bearings themselves and the pressed-in steel cones, nothing is truly perfect. There's no shake in the crank, but just the slightest, you can just barely feel it, 1/1000th of an inch. And I've tightened down the jam nut. very securely. And when I roll it, you won't be able to hear this on tape. But yeah, there's a little bit of rolling sound. It's not as gritty. It's not gritty like it was before. It's a clean bearing. And because I've used stiff grease, and because these parts are not perfect, that's as free as it's going to be. Of course, with use, it may run in some. But you see, that's pretty free. If its own imbalance will cause it to move a bit. So I'm going to call that a job. All we have to do now is put our pedals back on. And since you've seen me take them off, you don't need to see me put them back on. I'm going to wipe off everything, and that's it for the bottom bracket. Now I want to zoom in again. This takes a moment. I want to show you why this sort of thing is not sealed, and why it's, if you ride through sand, let's say you go through muddy water, what's happening is water and sand gets splashed up into here, and unless there's a thick layer of grease oozing out, it's going to incorporate with the grease, and you're going to get sand and water in there. It mixes with the grease and degrades. That's why you want to service this type of bearing from time to time if you pedal a lot. But like I say, my fix is going to be to insert a Zerk fitting, a grease fitting, and pump a very light-bodied grease through this thing. That means grease will always be oozing out of here, and I'll be wiping it off all the time from both sides. It'll make a mess. But it'll keep my bearings in good shape. Alternately, I could make a sort of a felt seal to tuck in there, and that would stop the worst of the sand. Just as you're riding along, road grit that's thrown up by the front wheel gets into this. So I could spend a few dollars and buy a better set of bearings and get better results than this, but this is pretty good. It's better than it was. Certainly more free than it was. Didn't have any freedom before. But I have to hand it to the bicycle factory for the quality of parts that they were able to use for inexpensively made bike like this. They adjusted everything quite well. No problems. No problems. All right. End of project. I've learned something. And you've learned not to watch any more of my videos. See? You've been warned.